new webinar series, EvoInsight. We are thrilled to have you join us here on this journey. If you're new, welcome. This series isn't just about new content, it's about starting a new conversation, new community, and a whole new wave of insights. And for our next episode that we want to share with you and talk a little bit about is trends in the industry and what we're seeing. So I am super excited to introduce our next guest speaker for today, Ian Gordon. He is from the UK and he's got a fascinating background in mechanical and general engineering and of course sales, being our general sales manager. He'll be answering a few questions for us today and covering some unique insights in today's session. So grab a coffee, find a comfy seat, and let's dive in. Ian, thank you for being here today.
Thank you. Thanks for inviting me, Lindsay. Great to be here.
Good. Okay, so as I said, we've got a topic of trends in the industry. We're going to view what the markets are doing and what we are seeing. So I'm going to dive into a couple of questions throughout, and then we obviously got some fun question at the end. Are you ready?
I am ready. Go ahead.
Let's dive in, drum roll. Let's go. So from your perspective, how does Evoscann and evolution measurements solve some of the key challenges organizations are facing today? And where do you see our solutions fitting mostly within the broader industry landscape?
Great. Thanks for the question. We have a long history working with pressure, and we've become more and more focused in recent years on aerodynamics. Going back quite a few years, I guess many in our team have got probably 30 years experience of measuring pressure or measuring with instrumentation. So we have a good background to be able to help people look at new applications and assess applications for the right fit of a product. We always say that in order to improve a process, you need to measure it. So by adding measurement, it allows you to work out, start with a benchmark of what do we have and where do we go from here. Okay. On the pressure side, like I said, more than 30 years experience in many of the people in our team. We've worked with ScanEvolve on pressure scanners particularly since about 2005, 2006. We're very proud to still be their representative and their support channel. And then probably about 10 years ago, we added Evoscann as a product to our product range. And that enabled us to get more into a big area of passion, personally for me, which was motorsport in particular, but also aerodynamic measurements across a wide range of applications. So yeah, the Evoscann came along. It kind of broadened the field in terms of bringing fewer channel measurements and more portability and more lightweight products to be able to make them something that you could fit to a car which could potentially get wrecked and obviously has a very harsh environment compared to something like a traditional wind tunnel or a testing laboratory where it's a much more benign environment. So I would say that the Evoscann has brought along the ruggedity of those applications, and we've expanded that range in the last 10 years to bring more and more products into that range and get involved in a wider range of applications. So when a customer comes to us and talks aerodynamics and pressure measurement, then we've probably got something within our range to fit. And of course, we'll always choose the best instrument for the job. Depending upon all the application requirements.
Yeah, I do find our product range and our applications very interesting. Like you said, there's over 30 years, and you yourself have been in the industry a really long time. So put all of you guys together in the same boat. The amount of experience and years of experience in the engineering background is just fascinating to me. And like you say, the products that we have are so unique. And they fit so many unique applications at the same time. So you guys are always exploring and digging deep into different applications when a customer comes to you, which is, you guys got the exciting job.
Yeah, we have. And we're really proud of the customers that we have. And you know, we all almost joke sometimes that unless a customer is in a cool industry, then it's probably not for us. Because most of our customers are in cool industries. And, you know, whenever I visit customers, I was with a Formula One team yesterday, and of course, it's all wow factor, and it's such a privilege to be involved in those applications, and it just feels great to bring something to those applications with our passion and with some value, and then when we've designed a brand new product, to take that to an organization that says, wow, this is really cool. That's what we need in our business. That's going to help us. And that can be a wide range of businesses. We always think about cars for aerodynamics or aeroplanes. But of course, a lot of people are doing aerodynamic research. It could be HVAC, or it could be wind turbines or gas turbines. There's a lot of applications. And then, of course, overarching over that whole area is education. And we have some great connections with education, with the universities. And we love working with the students to try and engender passion into them on applications. So, for example, in Formula Student, and many of our products are used throughout universities and have been used for many, many years. Scannervalve is around since 1955. So yeah, quite often we'll find equipment in universities that's been there since the 1970s and still working happily. And work with them, kind of bring them along and kind of encourage them to follow their dream, really, because many of these guys are really lucky to be following their passion. They're not doing something because they're expected to, but because that's what they love. And that's a great place to start.
Well, to sum that up, you do what you love.
I do, yeah.
Every day in, day out, you're doing what you enjoy and what you love. So that's great.
Do.
Okay, let's move on to the next question. So, what gaps do you see in the market that Evoscann and Evolution Measurements again addresses particularly well?
I think it's the flexibility of our products. I think the Evoscann in particular adds something into the range of pressure measurements, almost at the lower cost end, but also the lower channel count end of the range of pressure measurements. So traditionally with Scannervalve, we would be offering a 64 or a 32 channel pressure scanner. We now have 8 and 16 as well, so that extends our range. And it's also from the perspective of lightweight and ruggedness of the product, to be able to be used in a wider range. There are emerging markets such as UAVs and drones, kind of lightweight unmanned flying vehicles, for example, and they need fewer channels. They also need to be light, also need to be rugged, because these things can be treated quite harshly. And potentially sometimes the scanner can become a consumable item. If a drone was to be damaged during a flight, then it's relatively affordable to not be a big disaster when you lose a scanner, for example. So yeah, they become a little bit more commoditized from that perspective. And then I think, as we mentioned earlier, the big thing with Evolution is to be able to advise on those applications. Yeah. And we've also expanded into other areas of aerodynamics with other measurements, such as the Streamwise ProCap, and also some measurement flow probes, to allow us to offer a much more a wider range of products for into those applications. And then we also offer there's a huge range of Scannervalve accessories. So quite often a customer will, regardless of what equipment he's using, he'll probably need connectors and tubulations for aerodynamic research, and he'll probably need tubing, things like that. And of course, that's bread and butter business for us. And we'll often be asked to supply kilometers of tubing for these applications, like in a wind tunnel model, regardless of what other instrumentation is being used. So yeah, I'd like to think that if somebody is doing aerodynamic testing, then we have a solution for them in terms of measuring pressure, flow, velocity, and being able to help optimize their process or their product. And again, that can go from a simple wing through to a complete aircraft.
Great. Yeah, I do think I wouldn't even say that we fill a gap. I think we just cover a lot of industries, and most of our products, any of our products, if a customer comes to us, we will always find a way to help, because like you say, we've got ProCap, we've got Scannervalve, we've got Evoscann, even DMA. So we've got such a range of products that will help in any solution for a customer.
I'd like to think we're considered as a bit of a trusted advisor to customers to be able to make a reasonable solution. If we can't do it, we can also say we can't do it, or we can recommend other people that can assist. But hopefully we can help the customer get to a solution in a fairly credible way.
Yeah, definitely. And like to your point, I think you're going to always find a solution first. You'll always, I mean, like we spoke earlier about the over 30 years of experience you all have, putting all your brains together, you'll definitely come up with something,
Right.
and at least figure something out before going back to a customer that you absolutely can't. So
Sure.
yeah, no, it's definitely some exciting products that we have in our range.
We do.
Okay, so I'm going to move on to our new products because it's an exciting topic. So let's talk new products. Evoscann recently launched a couple of new products. How do these new pressure scanners build onto our existing platform of scanners?
Yeah. 2017, we launched the first Evoscann products. And over that time, we've been supplying those into the market, many thousands of those into many, many applications. And we've listened to customer feedback and obviously customers using the product and being very happy with those. But we always kind of keep an ear open about what could we do better in terms of the product? What could we add to the product or remove? Or, how could we modify the product to make it better for you? And we've listened to the feedback from people. And of course, you get many varying opinions. There's a lot of people would push for more channels, but in many cases we've seen it's much better to go with more units with fewer channel count. So some time ago we had a request from a couple of the F1 teams that said, would you do a 4-channel scanner, for example? And we said yes, we possibly would. We tested the market, and there were other teams that said we probably wouldn't go the 4-channel route, but okay, interested to see what you have. And then we worked on that product in probably in the last year, I would say. And then where we could, we extended the product capability to be kind of Evoscann 8 or 16, but in a 4-channel package. And then also look to make it lighter and potentially faster and go to a higher operating temperature range.
Because why not?
Yeah, exactly. Well, yeah, as long as there's a market demand for that, for sure. So we came up with the Evoscann P4A, which is this 4-channel pressure scanner. So as you can see, extremely small.
Yes.
So the chance to fit lots of those into a wing section or into a very, very small aerodynamic section where you don't need so many measurements. So, for example, a small wing element or a duct of some kind, like a brake duct, for example, is a good application. And then we developed the 4-channel scanner, which had all the same look and feel and the same connectability with canvas in there, but also, making it smaller and lighter to go into more areas. So I would say that in many of the applications for those, it would really be areas where there's just not enough space to fit a traditional scanner.
Okay.
And we know people that have been using pressure sensors in those areas who would prefer to use a scanner for a number of good reasons.
Yeah.
With Formula One in particular, they've also added CAN FD to their ECU. So we've taken the chance to add CAN FD to this product, so that makes it fully compatible with the 2026 Formula One cars with their new ECUs. And we've successfully launched that product and already had supplied quite a number of units, especially in the Formula One, but also into things like drones where their small size and weight are absolutely critical.
Yeah.
So that's been really, really well received so far. And for me, if I drop it into a customer's hand and he doesn't say wow, then he probably doesn't know what he's really looking at. So I think most people don't expect the pressure scanner to be so small.
Yeah.
Another good example is the manifold. So we with the older product, we didn't have a separate manifold. All of the tubulations just went directly into the scanner. And on a race car, for example, if you wanted to make a quick change, you would undo 2 bolts instead of undoing all of the tubing. And that's even more important on the larger scanners. But you undo the 2 bolts and you can quickly remove the manifold, leaving all of the tubing in position without disturbing that, without losing time, without wasting time. And even in a wind tunnel between measurement runs, that just reduces the downtime in terms of swapping out models. And of course, you have all of the tubing in the model, which you want to connect to your scanner. You want to do that as quickly as possible. So, and then this will go to 1,000 hertz, so very fast response rate, so scan rate. So that allows it to go into some additional applications where we wouldn't have gone before. And then there's the P16. So we also have a 16-channel version. So this is the 16, which is just a little larger, and but it's got all the same principles. We have a AV mounting plate, which allows it to be mounted much easily with just 3 bolts, or you can take the plate off or specify it without the plate, and then you can probably build it into some kind of molded housing or something like that, however you want to fit it. And again, we've got the removable manifold. So you remove the 2 bolts, and that takes off the whole manifold, complete with all the 16 tubes, which allows you to do a really, really fast swap. So the existing P16 and the P8 are still around, but we've added these to the range where the customer particularly wants even smaller, or he needs CAN FD, or he prefers a manifold. So we're still offering the original product as well. We were fortunately, we didn't have obsolescence issues or anything like that, so we could continue if the customer prefers to use that one.
I can imagine the removing the manifold being hugely beneficial, especially to points in race cars, because there's time is so constrained as it is. So the fact that you can just take it off, replace it quickly, or repair it if you need to, and put it back on and keep going. So yeah, to your point, it's lighter, it's tiny. And when we were introduced to it, I think it was in December, we were told about these new launches, and we all said, wow, how is it even possible that we've gone even smaller, even lighter, and then still making it better? Like to your point, the 1,000 hertz scan rates, it's improving, but you fitted it all into that tiny little, like, I'm no engineer, but I'm like, I don't know how that works, but it's impressive. So really good, really great products. We were it's obviously, you've mentioned in the Formula One applications and drone applications. Any other applications would work well for those too?
Yeah, we've gone into lots of applications of all kinds of aerodynamics, really. I think things like HVAC and the UAVs that we mentioned. In terms of motorsport, we're in most of the categories of motorsport now. I think pretty much all of the MotoGP teams are now using Evoscann, and that's a fantastic market to be involved with. Those bikes are very, very experimental. Lots of aerodynamics going on, lots of Formula One engineers becoming involved with the MotoGP bikes. So yeah, almost at every race you see many advancements happening with all kinds of weird and wonderful wings and various aerodynamic appendages. And of course they're all experimented upon, and again lots of measurements to try and improve their understanding of whether it's positive or negative, and then help them go in the right direction to develop their performance. So yeah, it's great to be involved with those. Things like wind turbines, we're also into wind turbines. There's lots of measurements done within blades or within the towers of wind turbines. And traditionally, I guess you do all of that measurement in the wind tunnel, but by having the scanners, you can now go out onto the blades and do measurements directly on the blades. And of course, it's kind of complicated because the blade not only spins, it also bends and it twists. And the flexibility and the aeroelasticity means that it's difficult to measure it in a basic way. You need to do actual measurements on the blade to understand how it's twisting and turning. That's another great example of an application. And then with cars, quite often we find these days, in many cases, especially some of the more specialist cars, they will be tested on a track. They'll be developed with CFD, for example, not necessarily taken to a wind tunnel, but they'll be taken to a track, and they'll do measurements on the cars at the track to understand what they've got and how to improve it, and see how the performance is, without the time and the cost of going to a wind tunnel and building models and things like that. So it kind of appeals to people with a wider range of resources that might not have the time or the resources to do the wind tunnel measurements. So yeah, that kind of expands our range as well. certainly things like trucks and buses, we've also got involved in those applications, which are obviously a bit less cool than a racing car, but still pretty cool.
Yeah,
So,
that is cool.
we've got involved with those as well, which is just great.
So out of interest,
Yeah,
let's just talk about the car. Where would you place that scanner on the car?
it really depends on the application. So there's always a wide range of applications depending on the type of car it is. So your average EV running around on the street, they'll be looking at aero noise and aero vibration, and especially things like cooling. So getting cooling air going through the ducts and doing lots of measurements around that, because having the right operating temperature for the batteries, motors, and inverters is directly linked to operating range. If it was a race car, you're probably looking for downforce. So you're looking to try and get as much downforce as you can, because that helps cornering. So quite often the scanner would be placed looking at the floor or the underside of wings, aerofoils on the car, and you're really looking to drive as much downforce as you can. Sometimes you're looking to reduce drag. So yeah, you'd move it around the car. Lots of applications, lots of areas on the car where you could potentially fit a scanner. And quite often you're looking at all kinds of ducts, like brake ducts or cooling ducts, anywhere that's creating drag. So yeah, it really depends on the application and what kind of car you have. So
yeah, that makes sense. And it's definitely, so if a customer says I'm trying to reduce drag but also want to measure, I don't know, like you said, it goes on the bottom of the car, but then they also want to reduce drag, that sensor can just move around. It's the same sensor, you're not needing multiple sensors, same sensor, you just move it around, but testing different aspects of what you're trying to get out of it, which is great. Like one product does it all.
And then we also sometimes, of course, we connect with lots of tubing, but sometimes we also connect with a pressure patch. So this is a scanner valve pressure patch. And we'd normally fit those into onto a surface, and then you can connect many of those to pressure scanners. And of course, they can be temporarily installed. We don't always need to drill holes and everything to put pressure tappings in. We can put the pressure patches on. And we use those quite a lot in, especially some pretty exotic sports cars with, very large, expensive sections of carbon fiber. When we pull out the drill from the toolbox, somebody will tackle you to the ground, and then we use pressure patches, which is great.
And they will start panicking.
Exactly. And then we've also used these on, not only valuable cars, but also historic cars, where you want to do some retrospective measurements on a car, which you really don't want to damage or to modify in any way. You just want to measure what you've got and understand it.
Where is that measurement coming out? So once you put it on the car, the scanner's on the car, are we using some sort of CAD system to measure it?
The data coming from the scanner. So the beauty of a pressure scanner is it's converting the millivolts from the sensors within the scanner. It's converting those into another signal. It's correcting those for temperature effects. And any other kind of incidental effects on the sensor. And then the output we get from that would be in PSI or millibar or something like that. And we would export that from an Evoscann. It would be exported via the CAN bus. So the CAN bus might be connected directly to the ECU on the car, or it might be going to a logger which is being fitted to their car. And then we'd gather that data, and it would either be saved or it would be retransmitted via telemetry. In the case of a race car, probably the telemetry route. But yeah, you just collect an awful lot of data, and you'd store it somehow that you can be able to look at that later and understand what you have. And of course, it's measuring hundreds of times a second, up to 1,000 times a second. So you're gathering a lot of data when the car makes a lap of a circuit. With something like a scanner valve, so that's a typical scanner valve, that's a 64-channel one. You would this could be 64 channels or 32 channels, and generally the output would be Ethernet, and then the Ethernet can be taken direct to a laptop. You could gather the data live into a laptop. We can do the same with Evoscann if we use a CAN bus to USB converter. But yeah, you'd collect a lot of data, numerical data, into your laptop, and then you can analyze that later, or you can export it, or use LabVIEW, something like that,
Okay.
to graphically analyze it. And yeah, you basically understand what you've got before you make some changes and find out,
Yeah.
Did you make it better? Did you make it worse?
Yeah. And if you're the winning team or not.
Yeah, exactly. You'll soon find that out. Yeah,
Great.
exactly.
Well, thank you for clarifying that. Very impressive. Because you see these scanners, but how it translates on the other end, and to your point,
Right.
it's gathering so much data, and it's either gonna help you make those adjustments or you're there already. You're good to go. So yeah, no, very interesting.
And quite often you're validating, you've done a computational fluid dynamics analysis. And of course, you've done that on the computer system, very sophisticated, based on CAD models.
Yeah.
And then ultimately, yeah, you think you understand your error, but quite often you've got to validate that by using pressure scanners on the real car, and then compare that to what you have from the CFD and understand any differences.
Okay.
And then of course it becomes an iterative process between the CFD, the scanner on the car, and the wind tunnel. And you have this iterative process of constant improvement.
Yeah, and I guess once you set up, you just keep running it over and over, because it's the initial setup that you've got to get it accurate, and then it's the little tweaks thereafter once everything's set up. Perfect. Okay, thank you for that. Okay, next question. So I'm gonna dive into the trends of the industry. What are you seeing right now, specifically in the automotive and aerospace, which I think we've touched on a little bit, covering those two industries.
Yeah.
But specifically, what trends do you see happening right now in those two?
I think the trends are really, I mean, in aerospace and automotive, there are massive changes going on right now. There's obviously some transition to different power units, and they need to be measured and understood. And of course, that has an impact also on the aerodynamics of these vehicles.
Yeah.
There are a lot of new vehicles coming out. So there's a constant trend. And I think people are more into looking more at the ecological effects of kind of car that they drive, and want to understand more about it. There are more and more regulations coming for sure, which mean that cars need to be even more tested.
Yeah.
So we see more and more applications coming for these vehicles. Same with aircraft. I mean, in terms of ecology and environment, aircraft are being designed to go further, to go faster, to use less fuel.
Yeah.
And of course, that is more and more development constantly. So, yeah, we see more and more people doing this. When we get to things like universities, they have more aerodynamics courses. They do more motorsport, for example.
Yep.
More automotive courses. So yeah, we see a lot of new applications emerging. And then we mentioned already UAVs and drones.
Yep.
And how they're becoming more and more prevalent. We're going to see more and more UAVs in our skies around us, literally in the coming years. And of course, a lot of testing is going into getting those ready.
Even cars nowadays, you get into I'm going to do a name drop, Tesla, for instance, and you think, I don't know how it's getting us from A to B. And then they're designing planes that are electric. And I was like, that's impressive. So that's obviously definitely a trend that's going to be coming up quick and fast, because it's 2026.
Yeah, sure. And certainly as measurement becomes more and more affordable and more available, then it's more usable. I think traditionally, if a scanner was only available for $30,000 or something, then you might move away from doing that on application. Yeah. But if we sort of commoditize that market a little bit more, then it becomes worthwhile to do things like that. And certainly accessibility for students, and being able to get their hands on product and use the latest products, so they're fully aware of equipment that's available in the market.
Yeah.
And then of course they're ready when they go out into industry, sort of a few short years later. So they'll have used our kind of equipment that they'll see when they get to industry, which is great. It's part of their learning processes.
Yeah, no, definitely. There's definitely multiple trends happening in the market, and you guys probably seen it more than what I am, because things are evolving so quickly. In the last 20 years, so much has evolved. So yeah, and the fact that our products have also evolved with the industries, but at the same time, our bread and butter products are still in today's markets. They're still
Right.
prevalent in today's markets, not necessarily our new products. Like our whole range has just kept up with every industry, which is great. So whether the trend is 20 years ago or the trend today, like our products still fit, which is amazing.
Sure. Yeah, absolutely. Yeah. Yeah.
Okay. So
Cool.
last, but probably the best question of the series today
Okay.
is, what did you want to be when you grew up?
I think you might have guessed already. I guess I wanted to
Can
be
I
an
guess?
engineer.
Can I guess?
Yeah, go for it.
Car racer.
It could be. Yeah, exactly.
But motorbike racing, not necessarily cars. Motorbikes?
Could be motorbikes or could be cars. I've always had a passion for both of them, really.
Oh,
So yeah,
close.
would either be a Formula One racer or a Formula One engineer, I guess. So yeah,
Oh,
it's great that I'm lucky to work in that environment. And I think I started Formula One, following Formula One in proper Formula One teams, which is just great to be involved with those. And then yeah, such a privilege that we can help them. And I guess things have moved on quite a lot, because when I was a kid, if you said you wanted to be a Formula One driver or Formula One engineer, I think growing up in the industrial northeast of England, which was all steel and coal mines and things like that, then you may as well have said, I want to be an astronaut, because it was probably equally as unlikely to happen. But of course, these days, there's a lot more opportunities, and now there are
yeah,
university courses for people to become race engineers and things like that, which is really
yeah,
fantastic. The opportunities are there. And I think the great thing now is that if you really have a passion for it and you have the dedication to follow it, then it's possible. So
yeah,
probably a lot easier these days to do that. I say easier. There's a lot more competition now, but at least it's a viable career route to get into automotive or aerospace or aerodynamics, something like that.
yeah.
So yeah, that's I would always say to people, follow the dream, and if that's your passion, try and follow your passion, whatever it is.
Go for it. Go for
So,
it. So did you used to drive when you were younger?
I
Or did
didn't
you
race
start
as
off?
such. I was a mechanic for a race team, like a
Okay.
local race team, and I was
Yeah.
kind of helping out from about the age of 10. And then when I was 16, I was able to ride motorbikes and drive cars on the road. So I did
Yeah.
that. Probably always far too fast. Got some penalty points to prove it.
And some fines.
Yeah, definitely. Oh yeah, it was great. And it was a rite of passage for us, I think, to get your driving license at 16
Yeah.
or 17 years old, and
Yeah.
then get the fastest car or the fastest bike of all of your mates, and then
Yeah.
prove it.
And learn the
So
hard way.
not that I condone speeding, but hopefully I've grown up a little bit since then, but I don't know, maybe not. So, but
And
yeah, so that's
what changed then? Which path following that, once you were a mechanic, what
I
changed
think
the path?
yeah, I think it was just I always had a passion for fixing things, so engineering and things
Okay.
like that. So then yeah, I went off to college and studied engineering for 4 years, and then I kind of developed a passion for instrumentation, using all of the thing I liked about instrumentation was it used lots of knowledge of all different kinds of branches of engineering.
Yeah.
And then so probably instrumentation was a more viable career route than trying to get into motorsport way back then.
And safer. Definitely safer.
Possibly, yeah, probably. Although if you climb to the top of a tower which has got an instrument on the top to look at it,
Oh my
then you
goodness.
probably realise that isn't the most comfortable
Yeah.
environment. And then slowly over the years, hopefully, the instrumentation and the motorsport, the two passions had come together really. So I end up in doing what I'm doing now, which is just great. So yeah, really enjoyed it.
And which team do you support in Formula One? Can I ask that?
I follow them all really, because I'm lucky to work with all of them to a greater or lesser extent.
True. That's true.
So yeah, I tend to follow all of them, and it's just great to see them, and it's interesting how the teams sort of overlap in a lot of ways. And
Yeah.
I'm kind of in a privileged position that I was saying to somebody yesterday that I was pretty lucky that I'd visited all of the F1 teams many times and been in many of their wind tunnels. So, which of course, if you worked for one of the teams, you would never get to see the other side of it.
True.
But then, of course, people move around between teams. So I guess over time they do see the different sides of it. But But no, I've got a passion for all of those teams. I love what they're doing. There's so much innovation. There's so much passion in the people that work in those teams.
Yeah.
And it's the same with IndyCar. We do a lot with IndyCar as well, and have a big passion for that. And this year already, I've been to an IndyCar race in Florida at the beginning of the season, and then I'll get to a couple more Formula One races, Holland and Spain in the coming weeks.
Great.
So, yeah, great, love it.
Perfect. Well, thank you for your time today, Ian, and thank you for sharing so much knowledge on our products, on our company, and just generally just what your background is, your passions are, and you get to do that day in, day out with our products, which is amazing. So thank you for your time today. Thank you for sharing with me and everyone else a little bit of insight and the trends that's going on in the industry and what we're seeing today. So thank you. And thank you for everyone that's going to take the time to watch this, and we'll see you on the next episode. Thank you.
Oh, thanks, Lindy. Bye for now.
Bye.